So now that we know how to extract, transform, and transform data, we need to look at what types of systems we can load that data into for a data warehouse. And there are several different options for designing data warehouses through different models. And the first that we'll look at is relational OLAP or ROLAP. And this was coined by the same person who coined the idea of a data warehouse, Inman, in 1991. The idea here is to create multiple relational data that has a highly normalized relational model based on the ER model itself. Um, a multidimensional or MOLAP system by Kimball uses multidimensional arrays to represent the data. And then typically what happens and what we see often is a hybrid model that uses elements of both the ROLAP and the MOLAP models to store detailed data in a relational form, but then aggregated data in a multidimensional form. And we'll take a look at how that works. On the relational side, we have a couple of different designs that are created. So the first of those designs is called a star schema. The star schema has two types of tables associated with it. And again, remember, this is relational, so these will be tables just like we're used to and familiar with. The first of those tables is a fact table. And the fact table stores unaltered and unaggregated data that we observe in our production databases. So it includes attributes that represent the dimensions that are of interest to us. A dimension table, on the other hand, is the points of the star in the star schema, and the center is the fact table. So let's take a look at an ER diagram, a basic ER diagram that shows us a star schema. And here we see we have an order, which is the fact table. And what are the facts? Well, we have order number, product number, customer ID, and salesperson ID. Those point out to the dimensions. But the facts are the date that the order happened, the unit price for the order, and the number of items ordered. But through this, we know which salesperson was associated with the order, which product was associated with the order, and which customer was associated with the order. So if we want to have a list of all customers, we could go through this dimension right here and list the customers with the orders that they created. And we could very easily move from customer to order to product, or from customer to order to salesperson. And that gives us a very fast way of, with as limited joins as possible, to get the data that we need to present. A second type of schema used in relational OLAP is a snowflake schema. The snowflake schema has dimension tables with additional dimensions because the dimension itself is normalized. So here's an example of that. That sounds like a lot of words, but all it means is dimensions can have dimensions too. So in this case, we have a product table that is a dimension of order, but it has a dimension associated with it as well called supplier. So this is a snowflake schema when you have dimensions that have dimension tables of their own. If we look at another way of organizing a relational OLAP, and this is happening on systems like SAP HANA. SAP HANA is organized as a columnar database. So column-based data is a lot easier to, as it turns out, to query than more complex data systems. So each attribute of the database is stored separately, but it's stored in such a way that it uses its relative position to determine what the records are. The values of the columns are then stored one after the other, and that allows us to easily compress and do very simple searching to find what we need. So it's very efficient for querying in some cases. In a lot of cases, if you organize the data correctly, it is very efficient. So here's an example. So in let's call it a file because it's really a column. So the column file has student IDs in it. So the first record has student ID 1001, second record has 1002, and so forth, all the way to 1020. So if we want to know the credits for student S1020, we can count 1, 2, 3, 4, 5, 6, 7. So that's the seventh record in the system. So we know that we can go to S1020, and we know that we can count 7 across to the last name Rivera, 7 across to the first name Jane, and 7 across to the CSC major, and then 7 across to 15 credits. So that person, instead of being organized in a row-based system, we have a column-based system. When we look at multi-dimensional OLAP, we have what is known as a data cube. And a data cube is simply a multi-dimensional matrix that allows us to represent the data that we're looking at. So you can view that data by the dimension of interest in the cube. So here's an example of this. We have, in this case, one dimension is the type, one dimension is the store, and one dimension is the month. So in this particular case, we have the face that's showing is the month of June, and we can see the number of dairy sales for store number 3, the number of grocery sales for store number 2, the number of pharmacy sales for store number 1. But these are all in June. Then you can rotate this cube if you want to only store number 3, or you can only do store number 2. So you can view this data, and it's much like a Rubik's Cube in this case. So you can view a particular side of the Rubik's Cube at a given time, and it only represents one slice of the data. So data cubes allow us to do a lot of different things, such as pivoting. We can rotate that cube to display a different dimension. We can roll up and display a coarser view of the data granularity by combining or aggregating data that we have displayed. So in our example, we could roll up on store and get all of the total sales for a particular store and what people bought at that store. You can also drill down. If you have data that is rolled up, you can then drill down and get more detail, much more detail on a dimension using finer granularity for that data. But that requires that the detailed data be available. So if you store it in your data warehouse, then it's much better than if you're aggregating data and storing the aggregation of that data. So this would allow for drilling into the data. You can also slice by examining just a part of that data cube and slice through it, looking at a selection of that data with equality conditions for one or more of the dimensions. So, for example, in the previous slide, we had month in the month of June. So that was a slice looking specifically at the month of June. Dicing is looking at a range of values in a selection. So if we wanted to dice, then we could dice based on the months of June through November or something like that. And then we would have a dice of all of those faces in the same result set. You can also do a cross tabulation where you're displaying totals for the rows and for the columns. in some kind of a spreadsheet-like display. Now, most data is not simply in 3 dimensions, so what we tend to have when we do this is a hypercube. And a hypercube is simply a data cube that has a dimension greater than 3, and that's often what we have is larger dimensions than 3. So we can do pivoting, we can do roll up, drill down, slicing, and dicing in a hypercube, but how would we represent that? And we don't really know. There's not a good way to represent a hypercube. So this is kind of an overview of the layout of data warehouses. The thing that we will focus on in this class much more is the star schema and the snowflake schema, but we will also look at doing some cube operations using roll-ups specifically in the next set of videos.